Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, Panama-Buena Vista Union School District, and Bakersfield City School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Chuck. Our phone tutors are here until 5:30, so give us a call here in Bakersfield at 636-4357. You can call us toll-free from San Luis Obispo and the other outlying areas at 1-866-636-6284. You can email us questions at dothemath@kern.org. You can watch the show online at dothemathonline.net. And look for us on social media. There's Facebook and Instagram, Twitter, and YouTube, and we'll see Skype today.
Indeed, we will. So we'll see what's going on with those Hornets out at Van Horn Elementary School in just a little while. Nice couple of days off last week. Well, just one day off, but we had both days off from math, so we'll have hopefully a lot of students calling in that didn't have an opportunity last week need to get ready for.
It was a weird week, 2 days and 2 days with the holiday right in the middle.
Right.
So yeah, it kind of broke up the
I'm glad it's not like that all the time.
Yeah.
Anyway, we do have phone tutors available until 5:30. Before we get to a call and our visit out to Van Horn, let's first take a look at today's Math in the News. All right, today's Math in the News, because next week being Thanksgiving, we might as well hit that a little bit right now.
Of
all
course.
Right? You a fan of pumpkin pie?
Yes.
Yes? All right. Well, here's a photo of pumpkin pie. I was looking, I don't want you to see the other side of these pages because we're going to quiz you a little bit. You put whipped cream on your pumpkin pie or no?
Yes.
Yes? All right.
Whipped cream or ice cream, yeah.
Okay. Here we go.
Sometimes both.
What percent of people do you think used canned pumpkin for their pies?
Of the people who make pumpkin pie, what percent
use canned pumpkin?
Wow, 75%.
Higher.
Ooh, yeah, okay, 85%.
Lower.
Lower, so 80%?
I'll give 79.
79%, yeah.
What percent used canned cranberry sauce? What percent of people serve canned cranberry sauce?
When I was a kid, I would have said 100% because I didn't know you could get anything but canned cranberry sauce. But it's got to be pretty close to 100%, I would think.
Lower.
Well, lower than 100%, 99%.
Much lower.
Okay, really? Like 60, 70%?
51%.
Wow, really?
51% use canned cranberry sauce. I didn't think that many people would be making their own cranberry sauce, getting the cranberries and going through that process.
No, 51% use canned cranberry sauce or use cranberry sauce?
Canned cranberry sauce.
Oh, okay, that seems low.
What percent of people use disposable plates and flatware?
For
Thanksgiving. For Thanksgiving dinner, we're going to use paper plates and plastic forks. What percent of people do you think use those?
Wow, I don't know, 50%.
47.
Wow.
I wouldn't have even thought that high.
I didn't think, I just picked 50 because I didn't think it'd be that high either.
Oh, here we go, you and your little whipped cream. What percent of people make their own whipped cream?
67%.
Lower.
53%.
Lower.
Oh, really? 42%.
48%.
48%.
48%. You ever made whipped cream?
Yeah, we very often use, heavy cream and
Okay.
yeah. We use the canned stuff just in emergencies.
Here's a good one. What percent of people have passed off a store-bought dish as homemade?
That's a good one. 71%.
No, not that high.
No, really?
10.
10.
10%.
Really? Oh.
So so those are just some facts that I found, some, nice little percents, and we'll talk about those. Here's some trivia questions, all right? So
Okay.
there are options here.
Okay.
All right? Name the company that came up with green bean casserole. Do you eat that?
Yeah.
Green bean casserole. Anyway, what company came up with it?
Green, okay, go ahead.
Del Monte, Green Giant, or Campbell Soup?
I was going to say, I was going to say Green Giant, but Campbell Soup is probably the one because of the soup.
Right. The turducken.
Yeah.
Have you had one of these?
No. I've heard of it.
I've heard of it also. I have not had a turducken as of yet. We want to know the state that this started in. Mississippi, Texas, Louisiana, Massachusetts.
Oh, okay. Massachusetts.
Louisiana.
Louisiana. I was going to say Mississippi, but Massachusetts, Mississippi.
The average Thanksgiving meal contains about how many calories?
1 million.
So I'm going to make it easy. Well, what do you eat on Thanksgiving? 1 million calories.
We eat a lot.
1,000, 2,000, 3,000, or 4,000?
Probably 3,000.
3,000 is correct.
Yeah.
That's about how many calories for the one meal.
Just
Now, if
depends
I
on-
remember correctly, daily caloric intake is supposed to be around 2,000, right?
Yes.
For the whole day.
Just depends
it's
on how many
Thanksgiving.
pieces of pie you have at the end. That's right.
What percent of white and dark meat in a turkey?
Give me the two.
So what percent is white meat? What percent is dark meat?
I don't know. 80-20?
What are you going the 80 with?
White meat.
Well, you're close. 70 white, 30 dark.
Oh, okay.
So fairly nice little Thanksgiving IQ.
Oh,
That's what
nice.
you're taking right now. All right.
Nice turkey.
America's favorite pie for Thanksgiving Day: pecan, apple, or apple. Again, apple or pumpkin. So pecan, apple, or pumpkin. Favorite one for Thanksgiving Day?
It's got to be pumpkin pie.
Indeed it is. Which one of these four items was served at the first Thanksgiving in 1621? Pheasant, venison, apple crisp, boiled potatoes.
I get to pick one of those.
Mm-hmm.
Boiled potatoes.
That's what I would have gone with also. Venison.
Venison.
Venison is the one.
That would have been my second.
So
my
anyway,
second
that's not all of them. You can take a look at those later on if you like. That is today's Math in the News. A little trivia and some percents and things like that.
Yeah, that's good. We take Thanksgiving dinner for granted, I think. I mean, there's a lot that goes into it, and there's a lot in there.
A lot of preparation.
Yes.
Have you ever had a fried turkey? These deep fried turkeys? You've seen these things because they're on the news all the time with accidents happening.
Yes, we've had one once.
And what do you think of that? Because I've never had one of those.
It was okay, but it was a deep fried turkey. We either have we actually have two when we go, a regular roasted one and a smoked, barbecued smoked turkey. Really good.
Deep pit turkey.
Oh wow!
It's very, very good. I've had that once, and that's quite good. 636-4357 is the phone number. We do have phone tutors available until 5:30. Don't forget, San Luis Obispo area as well as outlying areas of Kern County. That phone number is toll free at 1-866-636-6284. If you do call from San Luis Obispo and we do your problem on air, you automatically get ice cream from Doc Bernstein's Ice Cream Lab. Any flavor you like.
Yes.
And pretty soon we'll be unveiling the flavor that
that's right.
made when we were over there.
That's right.
And it's been a little while since we've been over there, so they made that, we ate it, but as soon as we unveil what that was, they're gonna make some more. So if you go over there, you can request the Do the Math special flavor that we came up with. That's right, yay indeed to ice cream right there. All right, there are some problems that some students are working on, and there are a lot of students that are working on equations. There are students even in elementary school working on them for the first time. Junior high students are working on them, mastering them, and there are some high school students that are working on them so they can move on to the next item.
Right.
All right, so let's go ahead and we'll work on one of those right now.
Okay, great.
All right. Let me find a good one for you.
We're spending a lot of time in geometry in high school, reviewing equations and using them in geometry. So.
All right, here we go. We'll just go ahead with this one. 55 is equal to 3, open parentheses, 2n minus 1, close parentheses, plus 2, open parentheses, n plus 5, close parentheses, solve if you would.
All right, so, well, normally we like the variables over on the left side, but we can deal with them on the right side. We're going to do the same thing we've been doing. We did a lot with expressions for the 6th graders, so we've got the same problems here with removing parentheses and then combining terms. So let's go ahead and do that. We'll remove the parentheses by using the distributive property here and get 3 times 2n is 6n, and 3 times 1 is 3, and we're subtracting. And we're going to add, and we're going to use the distributive property again. So we get 2 times n, there's 2n, and 2 times 5 is 10, and we're adding. So now we've got our like terms. Some teachers will actually have the students rearrange the terms using the commutative property and switch places with the minus 3 and the 2n. So we get our 6n and our 2n next to each other. So that'll be 8n. And we'll get minus 3 and plus 10, so that's 10 minus 3, which is plus 7. So that right side, when we remove the parentheses and combine terms, simplifies very nicely down to 8n plus 7. And we still get 55 over here, 55. So now we've got our basic two-step equation. We have to get rid of the addition and we have to get rid of the multiplication. So we'll get rid of the addition first. We'll subtract 7 from both sides because 7 minus 7 is 0. So on the right side, we get just the 8n left. And 55 minus, that's actually 55, minus 7 is 48. Now to get rid of that multiplication, we're going to undo that by dividing. And we divide both sides by 8. And 8 divided by 8 is 1n, which is just n. And 48 divided by 8 is 6. So n equals 6. If I put that back into my equation, I get 2 times 6 is 12 minus 1, that's 11, so that's 33. And 6 plus 5 is 11. 2 times 11 is 22. And it's very easy to see that 33 plus 22 is 55, and it checks.
All right, nicely done. And it does not take that long to actually check your answer to verify that.
I tell my students, take that extra 20 or 30 seconds to do that because you may have made a real simple mistake in here and gotten the wrong answer, but it's real easy to see in a few seconds that it's not going to work.
Right. Well, I let my students know. I go, when you turn your test in, you should have an idea what your score is.
Right. Yeah.
Because if you've done it, you've checked it, you know that it's correct. And if you've done it and you checked it and you're like, it doesn't work.
You've corrected it.
You know you need to do something.
Right.
Right, or you know you're just going to get it wrong. Okay. 636-4357 is the phone number. We do have phone tutors available until 5:30. However, we are always out and about on Tuesdays having a lot of fun at all of the different schools that we visit in Kern County. Right now we're going to go out to Van Horn, home of the Hornets, and visit with Marylou.
Hi, Mike. We are here live at Van Horn Elementary, the after-school ACES program, and I am with Mariana today. Hello.
Hello.
How are you doing today?
Good.
And what grade are you in?
I'm in 4.
And have you been here at Van Horn since kindergarten?
Yes.
Oh, so you're a true Hornet. Yes? Okay. Well, we have some problems we need to do, right?
Yeah.
And it's division. And it's long division, right? Okay, so let's look at this. We have 8,274,000 divided by 6. Yes? Okay, so what's the first step we need to do?
We need to divide these two.
Okay, why don't you go ahead and do that first for us?
So 6 goes into 8 one time. So then we're going to put our 1 right here, and then we're going to multiply these two, and we get 6.
Very good.
And then we're going to subtract these two, and we get 2. Now we're going to bring down our 2, and 6 goes into 2, 3 times without going over. So then we're going to put our 3 up here, and we multiply those 2, and we get 18.
Okay, should we move that 3 maybe over the 2 so we're keeping our place values lined up? There we go.
Okay, and then we subtract these 2, and we get 4. And then we're going to bring down our 7.
Okay, let's put that 4 here because we have 22 minus 18. Again, making sure our place value is all nice and lined up. So let's put our 4 there.
And bring down our 7. And 6 goes into 4. 47. 42 times, which is 7.
Very good.
And then 42 times 7 times 6 is 42. And then we have to subtract these, and we get 5.
Okay, again, yeah, there you go. Let's put that right there.
And then we bring down our 4. And 6 goes into 54. 54 times.
Okay.
Which is 9.
Very good. 9 times. So is there any remainder here?
No, because we have to subtract 54 from 54 and get 0.
So there's no remainder, right? We're going to check this. And I know that they were back in the studio, they were talking about always double checking your work. We can double check this because this is division, right? What's the opposite of dividing? Multiplying. So we can take our answer here and we can take our number out here, which is called the divisor. We can multiply these two together. And if we get this, then guess what? We got it right. So we're going to double check our work. So Mariana, let's go ahead and multiply this out and double check our work to make sure that we come up with 8,274. Okay? Okay, go ahead.
6 times 9 is 45.
Or how about
54.
There you go.
And then we bring 5 up here. 6 times 7 is 42. 42 plus 5 is 7.
Okay.
47. And then we bring our 4 up here. 6 times 3 is 18. And then we add that to it and we get 22. And then we add 2 up here. And then 6 times 1 is 6. And then we add our 2 and we get 8.
So did we get the exact same answer where we started?
Yes.
Yes, and you know you did it correctly. How about doing one more problem?
Okay.
Okay, let's go over here at this one. We have 4,141 divided by 7. Go ahead and let's take care of this.
7 divided by 41, without going over, you get 35. And 35 divided by 7 is 5.
Okay. And we're going to put that not over the 4.
We use bar for next up.
Right.
Now we have to subtract these two numbers, and we get 6. And then we bring down our 4. And then 7 goes into 64.
Well, if we know that 7 is
63, which is 9.
there you go.
Bring down our other one. And then 7 goes into 11 one time. So then we put a 7 right here, put our 1 up there. And then we have to subtract these when we get 4.
Now this one, don't we? Here we had no remainder, went equally, right? So here we have a remainder. So what we're going to do is this. Let's go ahead first and multiply 591 by 7. I'm going to erase this right here. So to double check, 591 times 7. Let's go ahead and multiply that out.
7 times 1 is 7. 7 times 9 is 63. Put our 6 over here. 7 times 5 is 35. And then we add our 1 and we get 40.
Okay, but we don't have the same answer, do we?
No.
What do we have to do to find out if we're right?
We have to add those. Add our remainder of 4.
Very good. Let's add remainder 4. And did we get the same answer?
Yes.
So yes, always remember that, yes, you still can double check, right? If we have a division problem, we could double check it with multiplication to get it right. Excellent job. All right, Mike, back to you at the studio.
Thank you to all of the Van Horn Hornets out there. Let students know also that we do appreciate them working on those problems. They are also being entered into our drawing for a family 4-pack to go see the Bakersfield Condors. You know, I should just say a 4-pack because some families are 3, 7. I mean, so we're just going to go with a 4-pack to the Condors from now on.
Good.
So every time I say family 4-pack,
it's just a 4-pack.
Right, just a 4-pack. Have you been to the Condors yet this year?
Have not.
We went, we saw one game, and there was a poor performance by the players, but nonetheless a fun time to go out and experience all the things that the Condors do.
It's just a different level of hockey right now, isn't it?
And we will be at the Condors game tomorrow. Tomorrow there is an afternoon game, actually a morning game, for businessmen, businesswomen, and then school field trips.
Oh, nice.
Where there's a lot of students that go out to the Condors game tomorrow. So we will be out there, and Devin and Hilda will be out there. So
nice.
It'll be nice to have those guys doing a little bit of math with the students out there. We'll have some contests and some giveaways and things like that. And then we'll be able to do a little bit of interviews with some of the Condor front office staff. And who knows, maybe we'll get Hilda on some skates down there. And
little one-on-one.
We'll see what goes on there. Anyway, here's a problem.
Okay.
A student, we'll just make her Hilda.
Hilda.
Hilda recorded the number of cake orders over the past 10 months.
Okay.
Here are the numbers of cake orders: 14, 25, 18, 34, 27, 31, 27, 15, 22, and 27.
Oh, good. I was going to run out of room. Now, I'm sorry, the last number was 27?
Correct.
Okay.
So we need to find the median, and then we'll expand on that from there.
Okay, so let's find the median of this list of numbers. And so we know that the median means the middle number. So to find the middle number, what we have to do is put these numbers in order so we can find the middle. We can't just go, oh, there's the middle right there. It can be the middle just randomly. We've got to put them in order from smallest to largest. So let's go ahead and do that quickly. We can just do that pretty easily. There's a 15, looks like 14 is my first number. And then so there's my 14. Then I've got a 15. Let's see, I've got an 18. Is that the next? And I've got a 25, a 22. Then my 25 is going to be next. I've got a 27, 27, and a 27. Now, even though those are all the same number, I still count them as individual numbers in terms of how many numbers we have and finding the middle. And let's see, I also have a 31. And I guess a 34. So let's check here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And down here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like I got them all, and I've got them in order from 14 is the smallest up to 34 and the biggest. So now to find the median, I'm going to find the middle. So I'm going to start on each end, and I'm going to take 1 on the front, 1 on the back. Then I'm going to take 1 on the front, 1 on the back, and Matt just pair them up. So there's 2, and then I've got these 2. And so it looks like my middle is actually right here. 1, 2, 3, 4, 5 numbers on one side, and 1, 2, 3, 4, 5 numbers on the other side. So it turns out because I've got an even number of numbers here, we don't have a middle number. So to find the median of this, I have to use both of these numbers to find the median. And I actually have to take the average of those 2 numbers to find what's exactly halfway in between. So I'm going to take 25 plus 27 and divide by 2, which gives me 52. That's 25 plus 27 divided by 2. So it looks like my median is going to be 26. So even though 26 isn't one of my numbers in my list, it's the median because it's the average of the two middle numbers.
Now,
so there's my median.
I'll give you an option. Would you like to do the longer part now or the shorter part now for the next?
But I'm still going to do the other part.
You're going to do both.
We're going to do both.
But would you like to do the longer now or
we
second?
might as well get rid of the longer part
All
first.
Right, let's do the mean. So we need the average of all those numbers.
Okay, so to take the average, all we're going to do is add these up. So let's take the mean, and we know the mean is the average. So this is the one that uses the adding and dividing. So I'm going to take all of these, and then I can add them up here in this order. So I'm just going to take 14 plus 15 plus 18 and just add all of these up. Let's see how quickly we can do that. Well, 14 and 15, that's 29. 18 and 22, that's going to be 40, right?
Right.
25 and 27, that's 52, we said down here. 27 and 27, that's 54. And 31 and 34 is 65. So if I add those up, now I'll do them again. I get 69 plus 106 is 52 and 54 plus 65. And let's see, what do I get? 65 and 69, that's 134, 106 plus 134. Okay, so I think I did that correctly, and we get 240, right?
Correct.
240 is the sum of all of those numbers. And then to find the average, I'm going to take that, and I'm going to take that entire sum and divide by the number of numbers, number of terms. So there's my average, and we got 240, and very nicely, we had 10 numbers up there, so it's very easy to divide by 10. So 240 divided by 10 is 24. So there's my mean is 24.
And let's finish it up with the mode.
So let's see if I can move this back up and still get, so I've got the median, I've got the mean, and the mode. The nice thing about the mode is I don't have to do any manipulating or any calculating. All I have to do is look at my list of numbers, and I've still got it right here, and find the number that shows up the most. So that's my mode down here, and it's the most. And let's see, I've got 114, 115, 118, 122, 125. I've got 3 27s and one of each. So it's pretty obvious that the number that's the most, it's the only one that shows up more than once, is going to be 27. And that's my mode for this problem. So we've got the mean, excuse me, the median was the first one, the mean and the mode for that list of numbers.
All right, nicely done. Thanks for that. Do remember we have phone tutors available until 5:30. We'll get to our phone caller and another visit out to Van Horn right after this. Today we're in San Luis Obispo. We're at Laguna Middle School, home of the Lancers, and today we're here to Today we're at Laguna Middle School, and with us today we have 8th grade student Derek. And are you ready today?
Yes.
We're going to do some work with some exponents.
Okay.
All right. So if I have something simple like 5 squared, what is that equivalent to? What does that equal?
5 times 5.
It's 5 times 5. And what does that equal?
25.
25. Because some students might see that and go 5 squared, 5, 2, and they might go 10. You see how some students might do that?
Yeah.
But it's actually 5 times 5, which is 25. All right? So we're going to work with some exponents and just whole numbers, and you're going to give me those numbers. All right?
Okay.
What's the first one?
5.
5. And another number?
2.
2. Don't guess where I'm going to put it. Just say the numbers and be surprised.
7.
7.
8.
Ooh, we could do 7 to the 8th power. That'd be cool, wouldn't it? We faced with. Okay, we'll do 8. And let's see. Pick a number. I'll let you choose. Which number would you like to square?
8.
The 8? Nicely done. Let's go like this. Let's go. Would you like to add or subtract, multiply in there?
Multiply.
Multiply? All right. What would you like to do here? Add, subtract?
Subtract.
Subtract. And what about this last thing?
Subtract.
Okay. Your call. I'm glad you didn't say multiply. You think you need something big. All right. So we're kind of going to do like order of operations now. Have you done work with those?
PEMDAS.
PEMDAS. What does that stand for?
Parentheses, exponents, multiply, divide, addition, and subtraction.
Right. Perfectly done. PEMDAS. And do you know another saying that goes with that kind of helps kids remember that? Now you said parentheses, exponents, and then multiply and divide kind of go together as well as addition and subtraction. Please excuse my dear Aunt Sally.
Oh, yeah, I've heard that before.
Okay, so you've heard that before. You have an Aunt Sally?
No.
But you'll always remember, won't you?
Yeah.
Okay, let's go. Okay, so what would you like to do first, according to this? Parentheses. All right, let's go ahead.
7.
Okay. And then what I would do is just bring everything else down so that you do one step at a time. Good. Nicely done. So you have your parentheses out of the way. Do we have any exponents to deal with?
Yes.
All right. We have no other parentheses, no other exponents. Do we have any multiplication or division?
No.
No. So we're just going to add and subtract. And when we have that, we're just going to go left to right.
Yeah.
All right. So talk me through this.
7 minus 7 equals 0.
Okay.
And then 0 minus 64 would be negative 64.
Perfect. There you go. So you got a little nervous when we had all these numbers up here and then we wanted to square something, but I let you decide that one, right?
Yeah.
All right. So there we go. So 5 plus 2 minus 7 minus 8 squared is?
Negative 64.
Derek, nicely done. Today we're at Laguna Middle School. We're in San Luis Obispo, and I've got 7th grade student Derek with us today, and we're going to work a little bit with exponents. You ready? Nathan?
8th grade.
Oh, 8th grade. I'm sorry about that. I thought you said Nathan. I'm like, I thought you said your name was Derek. Well, come here. You know what? You are the first person today that is going to be part of the blooper reel because of me. We were on such a roll with 7th grade, I forgot real bad. I remembered your name right.
Yeah.
And you did good by kind of subtly, like, trying to get me back on track. If I mess up again, just go, hey, old man, it's 8th grade, aren't you? Okay, here we go.
All right, still rolling, ready when you're.
Nice to see we have a blooper reel before we even start the season. All right, like I said, nice to see they have the blooper reel. I'm especially appreciative of those guys putting that together with the blooper. Yay, indeed, yay, indeed. No ice cream for the kids in the back now, though. 636-4357 is the phone number. We do have phone tutors available until 5:30. Right now, we're going to go out to Tevis. Cushy, how are you today?
Hi, I'm good. How are you?
I'm wonderful myself. Remind us, are you in 7th or 8th grade?
I'm an 8th grader,
All right.
and
Are you ready to tell us your problem?
yes.
All right. As soon as you're ready, let's hear it.
Okay, it says that a drink coaster in the shape of a cylinder has a volume of approximately 95.43 centimeters squared, and a radius of 4.5 centimeters. Approximately how many coasters would you need to reach a height of 7.5 centimeters?
Okay, so I got the volume and the radius, and we're stacking coasters. And what has the volume of 95.43? Can you read it again? I got some of the numbers, but I missed some of the details. So can you read the problem again?
Okay. A drink coaster in the shape of a cylinder has a volume of approximately 95.43 centimeters squared and a radius of 4.5 centimeters. Approximately how many coasters would you need to reach a height of 7.5 centimeters?
Okay, so we need to go 7.5 centimeters. Okay, so what we have to do is we have to find the height of this cylinder, don't we?
Yes.
So if we know the volume and we know the radius, we're trying to find the height. So if we have this cylinder, now I made the cylinder kind of small because it's supposed to be a coaster. I didn't want to make it really tall. But we're going to find this, that's an R. We're going to use the radius and the height to find the volume of this cylinder. Do you have a formula for the volume of a cylinder?
I think, isn't it volume equals base times height?
It's base times height, right? So we know volume equals base times height, and the base of a cylinder is what figure?
The base is the bottom part and
yeah,
the top.
And so what shape is that?
The circle?
It's a circle. So the base, we say something like big B, capital B is the area of the base. And we know that the base is a circle, so what's the formula for the area of a circle?
The area of a circle, isn't it pi times radius squared times height?
So pi r squared is the area of the circle, right? Mm-hmm. And then you're going to multiply that times the height to get the volume. So there's your volume formula, isn't it? Pi r squared h. So what we have to do is we have to find h, and then we have to figure out how many h's. Now I'm going to stack these things up, so let's make a big stack of coasters over here, right? Mm-hmm. And we don't know how many there are. We don't know how many there are. So we have to find out how many of these h's are going to go there, but we've got to find h first, don't we? So here's our formula. V equals pi r squared h, and of these different letters, variables, v, r, and h, actually pi also, which one do we know?
We know the height.
Well, that's what we're trying to find, isn't it? We're trying to find h, but you gave me some numbers, right? You gave me the volume, so we know what v is, don't we?
Yes.
95.43. What's pi?
Pi is 3.14.
So again, approximately, because you gave me an approximate value for the volume, right? We rounded off to 2 decimal places. What's the radius?
The radius is 4.5.
4.5, and we're going to square it, and then times it by h. So the only thing that we don't know in this formula is h, isn't it?
Yes.
So let's go ahead and solve for h. And first of all, we're going to clean this up, right? This side is 95.43, but this side is 3.14 times 4.5 squared, and Mr. Cushion's over there with a calculator. I know what 4.5 squared is. That's 20.25, but times 3, so it's going to be 60 something. Is that right?
It will be 63.585.
585. All right, so Chrissy, do you see where we got that 63.585?
Yes.
Because 4.5 times 4.5 is 20.25, if I multiply, and then 20.25 times 3.14 is about 63.585. So we're still trying to find h, aren't we?
Yes.
How do we solve for h?
Do you have to divide it like 63.58 by the volume?
Yeah, so what we're going to do is to get h by itself, we're going to get rid of that 63.585, aren't we? So we're going to divide both sides of this equation by 63.585 to divide that out and get h by itself, but we got to do this side also, don't we? So again, going to my handy calculator, this I know is easy, that's 1, but what's 95.43 times 63.585?
Do you times it or you divide
Well,
it?
we're dividing. See, we had this equation, and it was being multiplied by h, so we divided it to get rid of that.
Well, I think she's asking that because you said multiply but meant divide.
Did I?
Yeah.
I'm sorry.
So
Okay.
not a problem. But when we go ahead and do that, we're going to get 1.5. Now, I'm going to give you a couple of numbers, and then you can figure out where you want to round this to.
Okay.
So it's going to be 1.50082.
So I'm going to take, let me get this back here. Everything's been to 2 decimal places, so let's go ahead and just round this off to 2 decimal places, and we'll say that h is 1.50, or just about 1.5. Very, very close.
Right.
So it looks like h is 1.5 centimeters. All right? So you see where we got that?
Yes.
That was that division. Now, we're going to stack them up, aren't we? We're going to stack up these coasters, and we want to know how many of these 1.5 centimeter coasters does it take to make 7.5? So there's a couple of ways we could do it, right? We could just start counting them. If I had 1 of them, if I had 2 of them, 3 of them. But my question is, how many of these are in there? So the easiest way to do this problem is, let's divide this up into coasters, right? Let's take that 7.5 centimeters and divide it up into 1.5 centimeter coasters. Right? So there's where division comes in, isn't it? So let's see, what happens when we divide by a decimal?
Don't kick it off to the wall, like my teacher taught me, like you're supposed to kick the decimal to the wall, so the decimal inside, like the decimal inside the equation, like it leaves, and then you add it to the other decimal that's outside. Okay,
so we've got 7.5 on the inside, right? And we're dividing by 1.5, but we don't want to divide by a decimal, do we?
No.
So let's move that decimal point, correct? And make that a 15 on the outside, but if I move that decimal point there, I have to move this decimal point on the inside, don't I? And then I'll just bring that straight up. So instead of dividing 1.5 into 7.5, we're going to divide 15 into 75. Well, let's see, how many times does 15 go into 75?
5 times.
Let's see, 5 times 15, that's 25, carry the 2, and 5 plus 2 is 7, exactly 5 times, isn't it? So it looks like once we have used the volume and the radius to find the height, then we just divided the height into the number you gave me, right? That's 7.5, and it looks like my answer to this problem is 5 coasters. Should do it.
Nicely done. You still online with us, Cushy?
Mm-hmm.
All right. Well, you know what? Since that was such a great problem right there, we're going to send you home with a meal courtesy of our friends of Johnny Rockets. So congratulations on that. Thanks for that great phone call. We do have phone tutors available until 5:30 at 636-4357. Right now, we'll go back out to the home of the Hornets, Van Horn Elementary School, and Marylou.
Hi, Mike. We are again live here at Van Horn ACES After School Program, and I'm here with Ethan today. Hi, Ethan.
Hi.
And what grade are you in?
5th.
5th grade. Okay, now behind us, it looks like you're studying what?
Adding fractions.
Adding fractions. Okay, let's get to work on these fractions. So we have 4 over 8 plus 7 over 12. Now, can I just add straight across? Can I just go, oh, 4 plus 7 is 11, 8 plus 12 is 20? Can I do that? No? What do we have to do?
You have to add 4 times plus 7 equals 11. Then you're supposed to.
Before we add that, what do we have to do with these denominators?
Make Compare them?
Well, yeah. Well, do we need to find a common denominator? Do we need to find a number that both 8 and 12 will both go into?
Yes.
Yeah, we do. So let's do that first. We know 8 doesn't go into 12, does it? No. So we're going to start with 12, and I'm going to start doing multiples of 12. Well, what's 12 times 2?
12 times 2 is 24.
Is 24. Now let's ask ourselves, hey, does 8 go into 24?
No. Yes, it can.
How many times?
3 times.
3 times. So this is going to be our common denominator, is 24. Okay? So we want to put 24 as our denominator. I'm going to let you do the other one. Let's go ahead and make another line just like I did here over here and put 24. There you go. And we're going to do what we call equivalent fractions. You know what the word equivalent is?
Like adding or not adding, like
equal, right? Equivalent, equal. So we're going to need to change this 4 over 8 to something over 24, okay? So 8, that goes into 24. You said how many times?
3.
3 times. We know 8 times 3 is 24. Since I'm multiplying it by 3, my denominator, I want to do the exact same thing to my numerator. So what's 4 times 3?
4 times 3 equals 12.
Well, let's put that in our numerator, okay? So again, we just made an equivalent fraction. We know 4 over 8 is the same as 12 over 24. So now we're going to do the same thing with this other fraction. We need to change this from 12 to 24. So 12 went into 24 how many times?
2.
2. Very good. So we're also going to multiply that by
7.
By 2, right?
Mhm.
So multiply that out.
It equals 14. Put a 14 up here.
There you go. Now are we ready to add?
Yes.
Yes. Because we now have the same denominators, we now can go ahead and add our numerators. And what is 12 plus 14?
12 plus 14 is 30.
Okay. Is it 30?
Wait, no. I mean 28.
20, what about?
26.
Is it 20? Yeah, 26. Let's go ahead and put a 26 over what?
Over 24.
There you go. Now, that, do you know what that's called?
The quotient?
Yeah, well, this is kind of like it's called an improper fraction, right? It's improper because our numerator
is bigger than your denominator.
Yeah, you got it. Now, we need to change that to a mixed number, okay? So have you changed that to a mixed number before?
No.
Okay, I'm going to show you how. It's division. What it's really saying is I have 26 out of 24. So we're going to quickly divide that. So we have 26 in the house and we have 24 outside. This is what we were like doing with Mariana earlier, right? How many groups of 24 go into 26?
1.
1 group, right? And what is my remainder?
2.
2. There you go. So I know that I have one whole group with 2 and 24 left over. So 26 over 24 is the same as 1 whole and 2 over 24, which I still could even simplify down more because I could divide them both by what number?
1.
Oh, 2, actually.
No.
So what's 2 divided by 2?
1.
Put the 1 there. And what's 24 divided by 2?
24 divided by 2 equals 8.
Well, take it half. What's
12.
half? 12. There you go. So therefore, 26 over 24 is the same as 1 and 2 over 24, which is the same as 1 and
12.
112. Good job, Ethan. All right, Mike, back to you.
Hey, thank you very much for that. Nice to see all the kids out of Van Horn doing some great work out there. 636-4357 is the phone number. Speaking of some great work, let's get another great phone call right now.
Okay, good.
We'll go out a student from Lum. And Logan, how are you today?
I'm really good.
Let us know, what grade are you in, Logan?
I'm in 6th grade.
All right, as soon as you're ready, let's hear the math problem that you're working on.
All right. I want to try to solve 2.3n minus 3.2 plus 4.1 equals negative 6.
Okay, let me make sure I have that right. 2.3n minus 3.2 plus 4.1 equals negative 6. Is that right?
Yes, that
Okay.
is correct.
No parentheses? Okay, I just want to make sure. So the only thing we have to do in this problem is clean it up a little bit, right, before we start solving it?
Yes.
So what part of it needs to be cleaned up?
You have to first, you have to, well, because all the ends are on the right side, you have to add a like term.
Yeah, so we've got all of our ends together, but we don't have all of our numbers together, do we? So let's go ahead and get these numbers together, and you said combine like terms, so let's combine those like terms. We don't have any other end terms, but what is minus 3.2 plus 4.1?
Positive 0.9.
Yeah, because it's just 4.1 minus 3.2, isn't it, right? So that's positive plus 0.9 equals negative 6. Okay, now they try to make this problem look more complicated than it is by throwing in the decimals. So you have a choice, right? We can either try to get rid of the decimals, the fractions, or just deal with them, right? So which way do you want to do it? Just do the problem?
I want to get rid of the decimals.
Okay, so do you know how to get rid of the decimals in this problem and just deal with whole numbers?
Do you subtract 0.9 from positive 0.9 and then subtract it from negative 6?
So what we could do is, what you just said is, let's just use the decimals, okay? Because let's just use them. And so you said, let's go ahead and subtract 0.9 from this side and 0.9 from that side, right? So we're just going to solve this equation and use the decimals as we do the problem, okay? Because we know that 0.9 minus 0.9 is 0, isn't it? So on the left side of this equation, what do we get? 2.3n equals, now what is negative 6 minus 0.9?
Negative 6.9?
Yes, because they're both negative, aren't they? So here, when they were opposite signs, we had to subtract. But here, where they're the same sign, we add those two numbers together. Very nicely, I lined up my decimal points. Add them up and carry the sign, right? So it's really important. In this case, two negatives, when you add them together, make a negative, don't they? All right, now we've got 2.3n equals negative 6.9. How do you solve for n?
You divide.
Divide. Let's divide both sides by what number?
2.3.
Yeah, because we want to get n by itself, don't we? So we want to get rid of that 2.3, and we get rid of that multiplication by dividing. So divide both sides by 2.3, because 2.3 divided by 2.3 is 1. That's 1n. And let's see, what's negative 6.9 divided by 2.3?
Negative 3.3?
Well, let's see. I know it's going to be negative, and
I'm glad he said that, because I can see what he's trying to do.
Mm-hmm.
And he's doing it in his head probably, because when you actually go ahead and work this out, go ahead and keep going.
And here's where you got to be careful. If those were multiplication, you could reduce the 6 and the 2 and the 9 and the 3. But in this case, it's actually 2.3 divided into 6.9. And so instead of trying to reduce this fraction separately, what do you have to multiply 2.3 by to get 6.9?
Negative 3.
It's just 3, isn't it, right? It's negative, but you multiply 3 times 3 and 3 times 2, right? So 3 times 2 is 6 and 3 times 3 is 9, but it's only 1 3, isn't it? So it's just a whole number, or it's the integer negative 3 is our answer down there for the solution for n. And
nicely done right there. And Logan, if you're still online with us, since that was such a great problem, we're going to send you home with a meal courtesy of our friends at Johnny Rockets. We can give away a lot of those today because, once again, we do not have any shows next week because of Thanksgiving. So congratulations, Logan, on that. 636-4357 is the phone number. We do have phone tutors available until 5:30. We're going to go out, I believe, right now for our last time at the Van Horn Elementary and visit with Marylou and her guest. It looks like a familiar face from old Do the Math days.
Oh, yes, Mike. Again, we're here live at Van Horn Elementary, the ACES After School Program. And first of all, I wanted to thank our guest today, Mariana, who unfortunately had to leave a little bit earlier. And again, Ethan, for helping us out today. Thank you so much. You did such a fantastic job. And we have a little present for you here. We have a shirt, and we would love it if you would wear that and show it off and tell all of your friends whenever they need help to call where?
Do the math.
Yeah, do the math. And you know, the phone number's right on there, okay? So you can look down. And I have a really special guest here, the principal of Van Horn, James Lopez.
Nice to meet you.
Nice to meet you. And I hear that you actually were on Do the Math, one of the previous.
I was. The first year we started out, I was working as a phone tutor and had the occasion to get before the camera once in a while. That was always a little more stressful than answering a question on the phone.
Well, also, you're doing a lot of work here with school and the after-school program. Do you want to tell us a little bit about that?
Well, first of all, ACES is a wonderful program. Started years ago, Governor Schwarzenegger wanted to have a safe place for kids to go after school. And ACES has continued since then, and Van Horn has that program and has had it for a long time. Again, ACES after school, but we also like to have that bridge between what happens during the day to also happen, you know, when kids are staying after school on our site. And one of the ways we can do that is in the area of math. One of the supplemental programs we offer at our school during the day where students get about 20 minutes is a program called Accelerated Math through the Renaissance Learning Program. Well, what's exciting is that we have teachers that will stay after school and work with those students that are in the ACES program to give them additional minutes on this special program. And what's nice is that the program is available through the technology our district has purchased, new Acer laptops. So students are actually working on additional math problems at their level on their laptop computers, which is aligned with the direction our state is going to have technology brought into the classroom and for assessments to take place on those devices.
Yeah, the accelerated program is a really great program because I know the kids are able to work at their level. And then again, when you were saying about working on their Chromebooks, the kids are more, they see more of being able to do the testing, you know.
Well, you would hope that that would transfer over, that they are comfortable working on math problems that are showing up on a computer screen. And our school has the Acers that was purchased by our district, but Chromebooks are found at other schools as well.
Awesome. Again, thank you so much for allowing us to come out here today.
No, love your program. I wish I could catch it more often. I don't get that channel, but I do hear about different things you guys are doing and appreciate the emphasis on math. I'm a math major when I graduated from college, and such an important subject for students to develop those strong skills for the workforce.
Exactly. All right. And thank you again. Back to you, Mike.
All right. Nicely done. Thank you, Mr. Lopez, for allowing us to come out to Van Horn Elementary right there. And since he mentioned he doesn't have that channel, you don't need the channel necessarily. You can view anytime at dothemathonline.net.
Yes.
So let's find out who's going to see the Condors. We have a 4-pack going to...
It is Logan from Sing Lum.
All right, so nicely done. Congratulations on that, Logan. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, Panama-Buena Vista Union School District, and Bakersfield City School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.